All right, hello everyone. Today we are doing our first topic for our Algebra 2 review unit, which is graphing quadratic functions. This is definitely a topic that you guys spent a lot of time with last year in Algebra 2, so hopefully this is a good refresher for most of you. If this is new material, I mean, it's not new material, but if you feel like it's new material, hopefully this video will help explain everything to you, because I am going to go through things pretty thoroughly, right? Because this is kind of a good foundation for this class. All right, so here we go. So first we have to talk about our key parts of our quadratic functions. All right, so for those of you who are drawing a complete blank with what is a quadratic, so a quadratic is our parabola. It has equations that look like this, right? Y equals ax squared plus bx plus c. That's our quadratic standard form, all right? And then they have the U shape, right? So they're generally like a nice U shape like that, all right? We're not getting too much into like transformations or anything like that. We're just reviewing some of the basic parts of our quadratic function. So the first thing we want to talk about is our vertex. Our vertex is our turning point of our graph. It's either going to be the absolute maximum or the absolute minimum, depending on how our parabola is opening, right? Whether it's opening up or opening down. So our vertex, this is our turning point of our function. Okay, and like I said, it's either going to be, so it's either a maximum point, means it's at the very top, right? So that would be when our parabola is opening down, right? So it's either a max point or a minimum point, right? And that would be, point. Right, and that would be if it's a standard parabola, right, pointing up. So these are two scenarios. So here's our up parabola. This point right here, that's our vertex. Or if you have an upside down parabola, then right there would be our vertex, right? So it's our turning point. Okay, so I'm gonna make this a little bit smaller because those were pretty big. I didn't mean them to be big. I need to write some stuff there. Okay, cool. So to find our vertex, it's actually pretty simple. So there is a few ways to do this, but I'm going to show you, if you were given this function in standard form, what's the fastest and easiest way to find your vertex. All right, and that's to use this small little equation. All right, so the first thing you have to do is find the x value of your function, right? So you want to do, to find your x, it is x equals negative b over 2a. All right, that's going to give you the x value of your vertex. This is also what we call the line of symmetry. Right, anytime it's x equals something, right, that's actually, you can consider that to be a line, right? X equals our lines, and it's the line that's going to go straight through that vertex, cutting your graph in half. All right, we're going to use it not really as the line of symmetry, but we're going to use it as that x value point for our vertex. All right, now this is going to give us, like I said, the x value, but we still need a y value, because remember, points are x comma y, so we need that y value. To get it, all we need to do is take that value we got when we found our x, and we're going to plug that into our equation. So to find the y value, all right, all we need to do is plug that negative b over 2a into the function. And it's going to give us our y value. So then we'll have a nice pretty point, x comma y, and you're done. All right, moving on, we're going to talk about these x-intercepts because they are very important. Now, today we're not going to go too in depth with how to find x-intercepts. We'll save that for our next video. But we do at least need to know what x-intercepts are, and if, because today we're just going to do how to find them on a calculator, right? So we know what they are, and then we will talk about how to find them on our calculator. So an x-intercept is exactly what it sounds like. It's the point that intercepts the x-axis, right? So it's where your graph crosses the x-axis. All right, so where your function crosses the x-axis. All right, so that's what it is, right? Now, this is a really important term. We're going to talk about x-intercepts all the time throughout this school year. Generally when you're solving, so anytime you hear like solve the equation, it probably is, it means you're finding the x-intercepts, right? You're finding the x value for the function, right? When y is 0, what is x? All right, so that brings us to a next point of x-intercepts, right? If you're looking to find where it crosses the x-axis, that means your y value is going to be a 0. All right, so this is, so where a function crosses the x-axis, all right, your y value will always be 0. All right, and like I said, to find this for today, we're just going to use our calculator. All right, so for today, or I guess in this video, right? For today, use a calculator. And we'll talk about how to do that when we get to our example, if you don't already remember. All right, the other ways to find your x-intercepts for quadratics are going to be factoring, which is a big one, and obviously the quadratic formula. All right, we're going to go over both of those techniques in a different video. So today we're just going to kind of, like I said, we're going to use our calculator. Okay, so moving on to the y-intercepts. Now the y-intercepts are actually the easiest thing to find out of your whole quadratic. We probably should talk about it first, but I don't know. Save the easiest one for last, I guess. So the y-intercepts go kind of with the x-intercepts. So if the x-intercepts are where your graph crosses the x-axis, then the y-intercepts would be where your function crosses the y-axis. And that's what they are. All right, so this would be where, oops, I meant to change color. I don't want my colors to merge. So where the function crosses the y-axis. Now, if it's crossing the y-axis, that means that the x value must be 0. And that's actually what we're going to do to find our y-intercept values. All right, so we're just going to plug a 0. That's how I write my 0, so you know it's not an O, right? So plug a 0 in for x, solve for y. And that's it. It's pretty simple, right? So if you look at that standard form equation that I wrote up here at the top, if you plug a 0 in for all of the x's, right? Well, that's then just going to equal a 0. All of that would just be 0 because it's multiplication. So you end up with y equaling whatever c is. So basically when you're doing a quadratic function and you're in standard form, like this equation is right here, your c value basically becomes your y-intercept, which is kind of nice. All right, moving right along. All right, we're going into domain and range. So a lot of times students have a hard time with what is domain, what is range. Domain, just think of it this way. Domain is what your x values can be. So it's what you're allowed to plug into the equation. All right, so this is the possible x values. All right, what you're allowed to put into the function. Okay, so domain, all the x values you're allowed to put in. All right, your range, on the other hand, these are going to be your possible y values. All right, so this is your, sorry, I'm having hiccups. Possible y values. All right, so where I said domain, it's what you're allowed to put into the function. We call this an input value, right? Input. All right, that means your range, these are going to be output values. These are values that are going to end up coming out of your function. Right, so these would be output values. Okay, so domain, what you're allowed to plug in, range, what you're going to get out. All right, now, when we write domain and range, there are many ways that you can write them, and depending on who your Algebra 2 teacher was last year, you might probably write these in a specific way, all right? But I have talked to both the regular Calc teachers and the AP Calc teachers, and they have one standard way that they do like you guys to write your domain and range, and it's by using a technique called interval notation. It's actually super easy, all right? You're just going to use parentheses, and the numbers inside the parentheses are like the values that you're allowed to like go between, right? So the first value is like the smallest number you're allowed to have as your X or Y value, and then comma, and then the second number is the biggest value that you're allowed to have for your domain and range, or for whatever you're doing, domain or range, right? So this is called, like I said, interval notation. Because you're giving an interval of values that are allowed to exist, right? Smallest, comma, largest. All right, now for the standard quadratic function, you're allowed to put in any X value. There's no restriction. You can put in negative numbers all the way up as negative as you want to go, and you can put in positive numbers as big as you can go. So for domain, you guys are probably used to writing like all real numbers, right? So the symbol for all real numbers is like this fancy R. I don't want you to write it like that because we are going to try and get into the habit of using this interval notation. So you would write it using parentheses like this. You would say it goes all the way from negative infinity, comma, to positive infinity, because that includes all of the numbers. So comma, positive infinity. All right. And that's just every single quadratic function has the exact same domain. It's always going to be negative infinity to positive infinity. And next unit, we're going to actually get into parent functions, and we'll talk about quadratics more and why they have this negative infinity to positive infinity. All right. Your range is going to be, like I said, your possible y values that are going to come out. Now, with range, it's a little bit different. All right, because it does change depending on your quadratic. But basically what you're going to use to do your range is you're going to use that vertex, because that's kind of where your function stops and starts. All right, we're still going to use interval notation for this, but like I said, it's going to be a little bit different. We can't just say it's all real numbers because it's not going to be like that for the range. All right, so for the range, we have to kind of look at the vertex to help with the range. All right, so I can't give you like an actual example. We'll do the actual problem below here, but I don't have anything to kind of give you a guesstimation for what that's gonna look like. But like I said, we're about to do this example and then we can talk about it. All right, so, but I will say it does come from your vertex. And I'll show you in a second. All right, so here we go. Let's just do this example. All right, so we have this example problem here. This is something you guys definitely saw in Algebra 2. All right, so given the following quadratic function, find the indicated information and then graph the function. All right, so we're just gonna go through everything that we just talked about and then we're gonna graph. So here we go. Starting with our vertex, remember to get our x value, it's x equals negative b over 2a. And that b value, that's the coefficient in front of that middle term, right? So it's going to be a -4. So negative b, so for us, that's -4, right? This is ax squared plus bx plus c. So that b right there, -4, all right, divided by 2 times the a value. Now we just have an x squared. So if you don't have a number, that means that your leading coefficient, the number that's in front of that, is a 1. So a is 1 for this problem. Simplify, -4 over 2, that simplifies to -2. So the x value for our vertex is -2. Now we need to go through, we need to find the y value. So in order to do that, we're just going to take that value we got for x, plug it into our equation, and that's going to give us a y value. So that's what I'm going to do. So I have y equals, now instead of x squared, I have -2 squared minus 4 times -2 plus 2. All right, and then I can go ahead and use my calculator if I can figure out where my, there it is. All right, so I don't want to be on this. I just want to be second, quit. There we go. All right, so you could do this in your head if you're feeling extra fancy. I'm just going to do it on my calculator here. So -2 squared minus 4 times -2 plus 2 equals 14. All right, so that means that I have a vertex at -2, 14. All right, so with that being my vertex, I can go ahead and I can plot it now, or I can save it till later. I'm gonna save it till later, I think. Oops, there we go. No, stop that. right, there's my vertex. Okay, so x-intercepts. Now we said we're just gonna use our calculator for this. So what I mean by that is if you have a graphing calculator, right, I know mine looks a little bit weird. It's just a normal TI-84 or whatever. It just kind of looks funky. So just kind of go with it because it's only showing you the screen. So what we need to do is we need to go into y equals, and we need to put in our function. So we have x squared minus 4x plus 2. All right, and then we're going to graph this. Then we're going to push our graph feature on our thing. All right, and we're looking for where it's crossing the x-axis. Okay, now this looks like if it was crossing at like one of the dashes, that would be really nice because then it would just be a nice whole number, but it's not. It's kind of going off to the side. So I'm going to use the calc feature in this calculator. So it's right above the word trace. So if I hit second and then that trace button, it's going to pop up with the calculate features, and I want to find a 0. All right, so another word for x-intercept is a 0 of your function. So that's what I want to find. So I want to find a 0. All right, now what we have to do is we have to use the arrow keys on our calculator to go to the left and then to the right. So see how it says left bound? So I have to be on the left of my intercept, and I am, so I'm just gonna hit enter. And then I need to be on the right, so I'm just gonna move my little cursor to the right, hit enter. And then it wants me to like kind of guess where I think it's crossing. So I'm gonna go right there. It looks like it's crossing right there. So I'm gonna hit enter. All right, and it tells me that my 0 is this beautiful value right here. So I'm gonna go ahead and write it down. All right, so we're just gonna round to, I guess, 2 decimal places I think would be fine. So we'll do 0.59. You could round to 1 decimal place if you wanted. I just figured I would write it like that. Oh, I forgot to put my comma y. Right, comma, and then my y value is just 0, right? So there we go, those are zeros. All right, now I need to find my second one. So I'm gonna do the same thing. I'm gonna do second and calculate, and I'm looking for a 0. So I'm gonna scroll down. All right, and now I'm gonna do it with the other intercept point. So I need to scroll to the left, which I am to the left, so you could technically hit enter right where you started, but that's okay. All right, and now I need to go to the right of that point. All right, so I'm to the right, and now it wants me to guess where it's at. So I'm gonna try and put that cursor as close as I can to where it's crossing, hit enter, and that's my other intercept value. All right, so my other intercept value is gonna be, what is that, 3.41. So 3.41 comma 0. All right, those are my 2 x-intercepts. All right, now we need to do our y-intercept, which I told you guys was super easy. So remember, I'm just gonna plug a 0 in for x. So we have y equals 0 squared minus 4 times 0 plus 2. Well, this is just going to equal 0. So I have an intercept at y equals 2. So when x is 0, y is 2. Awesome. All right. Now we have a good enough amount of things to graph this function. So let's go ahead and graph this. All right, so I can put a point at 0, 2. All right, well, we have this negative 2, 14 first. So I'm gonna have to scale my y-axis a little bit because it doesn't look like my thing is big enough. So I'm gonna say that each one of these marks is gonna go by 2 instead of by 1. And I think that should be enough. So 2, 4, 6, 8, 10, 12, 14. Yep. So I'm gonna say that each one of these is going by 2. So and I'll just keep this one at 1. So my x-axis is just going by 1 because I think everything will fit if I go by 1. All right, so I need to plot a point at negative 2, 14. So negative 2, positive 14 is right here. Negative 2, 14. All right. Okay, so I just realized something. Our vertex is wrong. It's okay. It's okay. Some of you have probably already seen this. Some of you have been wondering the whole time, like, why did I do this? I dropped a negative sign. So we have to look at our vertex again. All right, so remember, the formula for our vertex is negative b over 2a. All right, Well, our b value is already negative. So this should have been a positive 4 over 2, which would have made this a positive 2 right there. And then when I plug it in, I'm going to get a different value. I was wondering the whole time when I was looking at the graph and we were finding our x-intercepts, I was like, that's not where my vertex is supposed to be. So it's not. We did it. I did it wrong. You probably did it right. You were probably the whole time going, Miss Leslie. All right. Anyways, we're rusty. It's been a long summer. All right. So we have 2 squared minus 4 times positive 2 plus 2. So this is 4 minus 8 plus 2. So 4 minus 8 is negative 4 plus 2 is negative 2. Yes. That is right. So this should not be 14. This should be negative 2. Excellent. Which means we don't have to scale our axis, which is excellent. It can just stay normal. All right. So positive 2, negative 2. That's our vertex. Excellent. All right. Now our x-intercepts are going to be at 0.59. So right there. And 3.41, so 1, 2, 3.41, something like right there. And then our y-intercept is 0, 2, so right about there. All right, so when we sketch our function, we get something that looks like this. There we go. Now, last but not least, domain and range. All right. So for domain and range, we are going to look at our possible x values. Now, there is no limit on our x values. We can plug in anything that we want for x and it will still be fine. So domain is going to be negative infinity to positive infinity. Perfect. All right. That is for any quadratic, that is your domain. All right. Now for range, we want to look at the y values of our graph. All right. We should notice that our graph doesn't have any y values below the vertex. All right. All of its y values are above that vertex point. All right. So we have to say, okay, well, where is that vertex point? Well, that is when our y value is 2. So our values, we won't do that yet. So our values start at 2, all right, comma, and then they go up for forever because we have those arrows pointing up, which means it's going to keep going to positive infinity. All right. Now we can put a little parentheses around positive infinity. The reason I didn't put anything in front of the 2 is because since our graph actually touches that point 2, we don't use a parentheses. We're going to use a bracket. All right. Now, parentheses versus bracket. Bracket is when your graph can actually touch the point that you have right there. And since our graph actually does touch that 2, we can include that point, so we use a bracket. All right. Infinity is a fake number. It doesn't actually exist. It's not really a number. It's a concept. So our graph can't actually touch infinity. So we use a parentheses when our graph can't really touch that number. All right. So I know this is a little bit weird, but you would think of this the same way as you would think of like a less than or equal to sign. So when you see a bracket, it means it's like less than or equal to, right? It's equal to because it touches it. When you see a parentheses, that means it's just less than because it doesn't actually touch that value. So it's the same kind of concept. You just have to kind of look at it a little bit differently. All right. So we are done. That is the final answer to our problem, and hopefully that will help you guys do your homework tonight. I'm sorry this video was a little lengthy, but it was the first one, so hopefully you all stuck with it and made it to the end of the video because that's what you're going to need to do your classwork for today. All right, well, it was fun, and I will see you guys on the next one. Bye.